Okay, welcome everyone to the EEAI Vision 2020 conference. This session is part of the K-12 formal education track and is titled Demonstrating and Facilitating Concepts of Soil Health for Secondary Education. Thank you to NIPSCO, Mary Lee Environmental Center of Goshen College, and the North American Association of Environmental Education for sponsoring the conference. Please mute your sound during the presentation and feel free to use the chat for questions, comments, or to share something relevant to the presentation. We'll open for questions at the end, but if you want to ask some questions during the presentation, feel free to unmute yourself and go ahead and ask. Our speakers today are Seth Harden, Joe Rorick, and Stephanie McLain. Seth Harden is the Upper Wabash River Project Director for the Nature Conservancy. He grew up in central Indiana and received his bachelor's in forestry in 2010 from Purdue University. While at Purdue, he focused his studies on natural resources management and environmental policy. He recently completed his master's degree in public and environmental affairs through the IU O'Neill School of Public and Environmental Affairs. He's also worked with the USDA Natural Resources Conservation Service and Indiana Farm Bureau Incorporated. Joe Rorick is the agronomist for the Indiana Conservation Cropping Systems Initiative, a program of the Indiana Conservation Partnership. He provides extension education and technical assistance on cover crops, no-till, soil health, conservation cropping systems, and research demonstrations. Joe leads the development and execution of soil health training curriculum for ICP staff and other ag professionals. He is a certified crop advisor specializing in sustainability and 4R nutrient management. Stephanie McLain is the State Soil Health Specialist for Indiana's USDA Natural Resources Conservation Service and has been with the Indiana NRCS family for 3 years. She works to educate farmers, landowners, conservation partners, agronomists, and policy leaders about the benefits of soil health in our cropping systems. Stephanie has worked in multiple states during her career, offering her the opportunity to gain invaluable experience and form meaningful relationships across the country. She was a soil conservationist in Vermont and South Dakota, and she served as a district conservationist for 11 years in Minnesota. Stephanie grew up on a row crop and dairy farm near Leota, Minnesota. She graduated from Southwest Minnesota State University with a degree in environmental science and agronomy. She's been married for over 20 years, has 2 daughters, and she currently lives in Brownsburg, Indiana. So thank you all for being here. We really appreciate it. I'll let you take it away.
Thanks, Stephanie. We appreciate being here. We're excited to talk to this group for the first time. And I've been told through a couple sources, it's this exciting and committed and dedicated group of educators. So we're excited to share some of our knowledge and demonstrations. So the introductions are done, so we can jump right into content here. So to give you a little bit of an idea of what we're going to be talking about today, here are our objectives. We're used to doing this in person with hands-on, so we're doing our best to do this virtually, but we want you to walk away potentially with the ability to instruct your students on some of these core experiments and demonstrate why they're important to soil health and soil. We are also developing a soil health field and lab manual, and it's an ongoing project. It's a little bit uncertain on the timeline. It's one of those things that got kind of pushed because of this year. But it's something that we want to provide to you all in the future whenever we do get it completed. So by participating today, you'll be put on the short list to receive that resource when it's available. And then lastly, we want you to be aware of resources in the field. So the organizations we work for are good examples. There's others as well that are great resources for information about soil health, specifically around education. And we want you to be aware of some of those resources. So we'll share a little bit about that at the end and make ourselves available into the future to help you all teach these concepts and provide you resources. So Stephanie and Joe are going to do a bulk of the explanation today. So I'm going to kind of jump in and let them start. And I think we'll start with Stephanie here.
All right, everyone. So I wanted to kind of start the presentation off with just some basics to get us really thinking about our soil and our soil ecosystem. So in a typical scenario where we're looking at soil that we would call a healthy soil, its composition is based and about 45 to 50% the minerals, which is what most people really think about, are sand, silt, and clays. So only a half of our soil actually is that mineral component. The other half of our soil is pore spaces, air and water, places for that air and water to flow through. And those pore spaces, or that nothing in our soil, is some of the most essential part of our soil. So a lot of people don't really think about that aspect, that pore space is an extremely important part of what forms soil. And then lastly, the other thing that is an important composition of our soil is that organic material. And that can be living organisms, our dead residues, and then the other one that talks about is the very dead organic material in our soil. And that's that carbon that's been in there for a very long time, stored in that soil. And those are all essential parts of the soil. But the biggest thing that I really want you to think about here is that when we look at this composition, that is when we talk about healthy soil. When we get into soils that are maybe highly worked, say in agricultural settings with tillage, that mineral component by volume becomes much greater, say 50, 60% mineral, and we're losing pore spaces. We're losing air, space for air and water in soil. And as we lose that pore space, we start to lose health. So again, we talk about looking at soil properties, and everything when we break soil down, we look at physical properties, chemical properties, and biological properties. And these are all essential to a functioning soil ecosystem. But Seth, next slide, please. The thing that we really want to think about here is that these properties aren't necessarily all equal. They're all essential, but without the biology in this system, we start to not be able to see those other properties occur. So again, we have our physical, our chemical, and our biological properties in soil, but the soil biology, that living aspect of our soil, that 5% that we were talking about, or that approximately 5% that we were talking about in the previous slide, that biological aspect of our soil is what manages or controls all of the function in our soil, or up to 90% of the function in our soil. And so what does that mean? It means that our soils are this living, thriving ecosystem that full of things that we don't really think about, but they're busy working to make that soil ecosystem their home. And those things, that as they make that their home, it really benefits us. So in about, it says here, in about a cubic yard of soil, we'll see all of these things here, you know, billions of bacteria and fungi, and then the rest of these larger organisms that we see in this ecosystem. And up on the top of this slide here, you notice it's got a bunch of cows, and essentially what it's saying is that in our healthy soil ecosystems, there is about the weight of 8 cows under an acre of soil of living organisms. So that's so essential that we keep track of that. And if you break that down even smaller, in a teaspoon of healthy soil, there's going to be up to 1 billion bacteria and 1 million fungi in just a teaspoon of healthy functioning soil.
So this is our first experiment here, and we're going to have 3 of these today, and Stephanie and Joe are going to talk you through them. But I wanted to put in what it demonstrates at the very front end from a layman's terms, just to kind of give you an idea of what we're trying to demonstrate. And this is a very basic understanding, but what this test experiments is the effect of land management on soil structure and resiliency, and that'll be explained kind of throughout. So I'll let Stephanie take it over from there and talk about the materials and maybe some alternatives for you all to use in the classroom.
So some of the materials that we use here is jars that you can use, canning jars. You want to flip to the next slide, Joe, or Seth, and we can kind of show the pictures here, right? When you start to look at materials, you can use a canning jar like I have in this picture, an onion bag, or you can go to Hobby Lobby and get some glass vases. There's a lot of different materials that you can use. But the goal here, especially with this one, is that you want to be able to have a clod or an aggregate of soil about the size of a golf ball, and it's going to be air dried, and we're going to put it in water. The other thing that is really important of thinking about these materials is that when you're collecting your soils, you want to get it from the top 4 inches of the soil surface. You want to make sure that you have the same soil type. And like Seth said previously, we really are wanting to look at the effects of management of that landscape, and then how that soil functions when we put it in the water. All right, so we have about a 5-minute video here, 4.5-minute video. I'm gonna kind of time myself as I'm walking through this as well, so I don't forget and start talking a whole bunch more. But as you can see here in this video, I just placed 2 golf ball sized chunks of soil into the water. These soils come from 2 different fields that are mapped as the same soil type, but they're managed very differently. The soil on the left, if you notice the header on the top, it talked about a typical cropping system with tillage and low diversity. So that would be looking at a field that's growing corn and soybeans, and after harvest, that field is worked or tilled and left bare over the winter. The soil on the right that we're zooming into right now is managed with a soil health cropping system. So it may be corn and soybeans, but there could be other crops in that rotation, such as wheat or alfalfa or other things like that. But also after harvest, that field is not worked, it's left undisturbed, and the field is then planted or seeded to cover crops. Something that will protect that soil surface over the winter and have living roots in that soil throughout the growing season. So when we put those two chunks of soil into the water, do you remember how I talked earlier about that air space and that pore space, right? When we put those chunks of soil in the water, that water is wanting to rush into those aggregates. And as that water is rushing in, it's pushing the air out. And that's what's supposed to happen in a functioning soil. So again, that soil on the right, we saw that happening. We saw some air bubbles pushing out of that as that water was pushing in. Whereas the soil on the left, and we're kind of going back and forth, that soil started to fall apart as that water was pushing on it. That soil just kind of slaked off and started to fall apart. I think we're going to zoom back here a little bit and we'll get another picture of this and we can kind of talk about this just a little bit more. But what makes a soil an aggregate versus a clod is that soil life. Those organisms that live in the soil, they coat those soil particles with biological glues. And as they coat those soil particles, it makes them water stable. And so you notice here on this healthy soil, any of those particles of soil that are sloughing off of that aggregate are just sinking right down and falling to the bottom of that tube. Whereas that soil that we would call unhealthy, that's being worked and doesn't have a lot of diversity, the soil particles are breaking down into their individual pieces of sand, silt, and clay, and then just falling apart. And that water is basically having all of those particles of sand, silt, and clay hang in suspension in that water. So we are not only having a soil issue here, right, where that soil isn't healthy, but it's also impacting water quality. Joe, is there anything else you want to add there?
Yeah, so I guess just a few tips for doing this test. We like taller containers just to be able to see more of that water column. It's a more striking view, but any container can work. I've used peanut butter jars, I've used canning jars, I've used just a vase or any container you have handy. And depending on your group size, any container can work really. You want these soils to be good and air dried, and for this test, you really do want it to be a pretty stark contrast between cropping systems, because this one, while can be very dramatic, but it also can be not very dramatic. We have a question, how long do you need to air dry them? And of course, the science answer is, well, it depends. You want to air dry them until they're dry. So it's going to depend on the ambient humidity. If you have a fan blowing on them, it takes maybe, I have collected soils, taken them back to a hotel room, put them on the vent overnight, and they get pretty dry. Of course, hotel rooms are very dry anyway, right? I prefer to have them dry for about a week if I'm going to collect them to store and put away, really. But you can get them dry, especially if they're sitting out in the sun with the fan blowing on them or the wind, in about a day and a half, really, depending on the size of the bed that you use.
A good way to do it is to set them on the dashboard of a vehicle or in a window someplace and just let them cook in the sun for a little bit. Yeah, but
We have a question. How long do you need to air dry them?
Oh.
I think I just did that one. But admittedly, most of Stephanie and I's tips are for being on the road. So her dashboard and my hotel room example are maybe not as useful to everyone. But that's typically where we run into problems, is when we don't have access to our hordes of soil beds that we have lining our garages and basements and sunrooms.
Yes.
So why it matters, we have some discussion points here, and of course these are all negotiable, right? You can fit these to your needs, but what we tried to do here is to make it specific to what they saw in the tubes, and those soils there, and then broaden out to what they see on a landscape or in your area. And of course, all of these can be tailored to whatever age group you're working with. So you might talk about things like what practices are being done, and how do those specific soils react in water, right? Stephanie talked about biological glues, and that would be one of the dynamic properties of soil that we referenced there in that first bullet point. But there are some inherent properties of soils that will affect aggregate stability, so clay content, and that may be something you want to just factor in whenever you're collecting the soils. What soil type do you have? Is it a silt loam? Is it a clay loam? That sort of thing. And can they be changed with management? So just, a basic definition, what is a soil aggregate? Soil aggregates are particles that are bound more closely to each other than they are to other soil particles around them. And then through time, so we saw those soils drop into the water, and then how did they react over time? These slake tubes are good for that, for seeing how they react initially and then continue to react over time. Does one fall apart? Does one hold together? And then just broadening out to the local area. So do you see bare soils? Do you see crop residues on the fields, especially now over winter? How do you think those soils would react compared to the soils that we saw in the tubes? And then what does that mean for the whole area, right? What does that mean for a watershed? How does that water then look when it goes into our rivers and our lakes and our streams? Just that sort of thing. So here's a couple of discussion points that can sort of get at what we're looking for out of these tests.
All right, so here is the second experiment we have for today. And you'll notice that I essentially copied and pasted what it demonstrates in here, and it truly does very much the same thing, but the experiment can be managed a little bit differently, and it doesn't require quite as much prep, and Stephanie and Joe will explain that throughout. So I'll let Stephanie start out by talking about materials, and then we'll jump into a video.
Actually, let's go to the video right now, Seth, because I can talk about those materials while we're doing this. This is just a brief video of me actually prepping the demonstration. So I've collected soil, and in this instance here for the video, this soil has been dried. But what's really nice about this slump demonstration is that these soils do not need to be dried. You can do this in the field live with soil that is moist or at field capacity for water. So this is a really dynamic demonstration, and it shows water stable aggregates. Again, so like Joe said, those aggregates will adhere or stick together more to each other than they do to other soil particles, and that has a lot to do with, so we're looking at these aggregates here, that has a lot to do with the living ecosystem in there. So again, your fungi and your bacteria help to coat those soil particles and hold them together. Your plant roots that are growing through that soil, again, are building pore spaces, and plants, when they're growing, they photosynthesize, and as they photosynthesize, they exude sugars into that soil profile, and that sugar becomes food for those organisms that we talked about. So again, this is how this ecosystem is being created. And so those water stable aggregates are essential for those organisms to keep their home stable. So that's why they coat those soil particles with those glues that they exude out of their body, and the hyphae line those aggregates and help hold them all together. So here we're taking these two soils, again, one managed with a no-till cropping system and then cover crops, and then the one that I'm working on right now in this video, again, has worked with a lot more tillage and no cover crops. And as I held that soil up to the video, you probably noticed that those particles were much smaller. They don't hold together as well. And we put them in the sink strainer like we did here, and then we can go to the next video. We take those sink strainers full of soil, and again, I just set it in there. We don't want to pack it in there, and I also don't want to mound it up too high. And you want to put those soils in a cup of water. And here I am filling little Dixie cups, but they can be whatever you have with you. Again, we've used canning jars. We've also used the little tiny bathtub strainers, and I've used shot glasses. So although it looks kind of interesting and a little bit, people wonder a little bit why you're carrying shot glasses with you in the field. But it's always for work.
If you think people don't look at your purchase orders, go ahead and try to buy a case of shot glasses. I promise you, there are people that do look at that and ask questions.
So here we took those two different soils that I had loaded into the strainers, and I put them in the cups of water. And so we can kind of actually see like a little miniature slake going on. So we see those soil particles falling out of the bottom of the strainer, but we are seeing one having more of that than the other. Again, the one on the left, we're seeing a lot more of those soil particles fall out of that strainer and settle into the bottom of that cup. And if you notice and you can see it in this video here a little bit, when I put those strainers in the water, the goal is to have the water just cover the top of that soil. Again, that's why it's important that we don't want to mound it up or again, pack it in. We want to have that water be able to kind of flow through those soil particles and see what happens with it. When you have those water stable aggregates, they just do a better job of holding together and again resisting those forces of water. You want them to set in these cups for about a minute, as long as the people that you're with can be patient enough to allow this process to happen. And once we take those out of there, we're going to look at what those aggregates look like. Just so we have about maybe another, probably 30 seconds or something here before we dump them out. Is there anything you want to add?
This test is good. Often you can look at the water, but that's not really the main point of this test. So the slake, you look at the water. This one, you really want to do this next part here. Yep. And that's really what this test is for. The water's just a bonus.
So when I take the strainers out, you want to kind of tap them up and down and get the free water out of those strainers. We want to kind of tap it up and get that out. And then once we kind of get that extra water out, you're going to tip those strainers right on the plate. And then after that, we can kind of look at them. So I'm gonna set these strainers up a little bit, and then we're gonna kind of look at them just a little bit, and then we're gonna kind of mess around and play with them. This is a great demonstration. It's very hands-on and allows people to kind of like touch and feel the soil. So the soil, I think we go to the one on the right first. Our healthy soil. Oh, we go to the one on the left. So this is our soil where we have less water stable aggregates. You can kind of see there's maybe little particles or chunks in there, but when we dumped it out, you notice it kind of just made a big massive pile. Whereas the soil here on the right, when we look at it, those particles are still more individual, and those aggregates are all kind of, again, holding together. So we're going to pick these up and we're going to kind of move them around. And again, that soil, do you see how it just kind of slides all over on the plate? It's just, it plops down on there and it just is kind of falling apart. And when you run your finger through that and you kind of open up that soil and you look at it on the inside, it looks like a mud pie. Because again, those aggregates have melted. So those aggregates that we're looking to see, we want to see them water stable. Those have melted. This other soil, when we start to look at this and move it around, as we're tipping the plate, it's holding in place, and the water's actually holding in that soil as well, because there's organic matter in there, and that helps to hold that soil in place and hold those aggregates together. And as you run your finger through this, you'll be able to feel those aggregates, and they're holding together that whole time. So this is a great demonstration to do with kids. Now, if you have a whole bunch of kids working on this, you might want to have small groups do this, because after about the third or fourth person, all of the soil kind of turns to mush. Now, the video that we're looking at now is actually what these soils look like a day later. So I let those plates dry. And again, that healthy soil, you still see those aggregates. You still see those particles. This unhealthy soil, it's basically a dried mud pie. It's the bottom of a mud puddle that we're seeing there. And that soil there that we're looking at right now is going to fight to infiltrate water for the rest of the growing season, because that soil has sealed up on the surface and is now crusted.
Perfect. I love the mud pie description. That's my favorite part of that one.
If we really want to talk about food, then we always talk about that healthy soil looking more of like a crumbly brownie or chocolate cake, and then the unhealthy soil looking more of like a mud pie or some type of a pudding. So again, there's lots of food references that you can bring into these.
So I really do carry around shot glasses, and the small, whatever size they are. They make a small size and a big size of strainer. This is a really valuable tool, and we use it as an in-field diagnostic tool when we're working with farmers and with educators to look for problems in the soil in field. The differences between this test and the slake test are really how long it takes. The setup is a lot longer for the slake test, but the differences can be a lot more graphic. This test is a lot faster. It takes 30 seconds or a minute for those soils to sit in the water, and then you pour them out onto a plate. So they are looking at aggregate stability, right? They're still looking at those soil aggregates, so some of the same questions still apply. But then you start getting into some differences. So we're down here at the third bullet point now. In the slake tube, you would want to look at the water, right? And then you can talk about water quality and why that soil is, why there's soil in that water in the tube, why that water's cloudy, that sort of thing. In the slump test here, you want to look over time, and Stephanie referenced sometimes you'll see the water coming off of those soils on the plate. And again, it doesn't have to be a plate. It can be a shovel. It can be a spade. It can be the tailgate of a truck, although it's messier and you have to go hose your tailgate off then. but any flat surface will work. You can even put it out on the ground if you really want to. But then over time, as those soils remain wet, you can take a look at how those soils continue to react or not in that water, right? So that unhealthy soil will release water from it because those aggregates continue to break down. And the water that would have been trapped in those aggregates is then released. And in the healthy soil, as those aggregates remain intact, you'll still get a little bit of free water that continues to drain through it. But those aggregates are able to hold together, so they don't release water. There's a couple of things you can do at that point. If you're just working with a group right then and there, then you might want to run your finger through it like Stephanie did and take a look at how it feels. You know, can you put your finger on top and push down? Do you think it'll hold your finger up? What does that mean if you're going to drive on that soil or have to walk on that soil? Are you going to end up with muddy boots or not? If you have the opportunity, you can let them dry. Or if you save your practice ones from the day before or a couple hours before and set them out in the sun, then you have an opportunity to talk about broader context, what's going to happen to those soils in the field as they dry out, right? So if a soil reacts like that in 30 seconds in water, what does that mean after a good hard rain? And then 2 weeks of sunshine? Then you get dry crusted soils, or do you get soils that are still able to hold together? You know, will water run off of those soils? So this test, you can talk a little more about the soils themselves and what that may mean in field, whereas this lake test is a little, I tend to focus a little more on water quality and things like that. Did I miss anything there, Steph? Do you have anything to add?
No, I think you did really great. I like your last bullet point here. What would a whole field look like, or an area look like, whether you had crusted soil or that unhealthy soil that turned to pudding, versus versus having that soil that was well aggregated and had those water stable aggregates? What does that impact on a soil's ability to be able to infiltrate water or not infiltrate water, and what would that look like on a whole field? I mean, so a whole field scale. So this is a great process to start getting kids to visualize the essential need to consider more critically how a landscape is managed and their ability or their role to have an impact on that. So again, this is, I really like that last bullet there, and how we, getting people to think on that larger scale.
That's a great lead into our last experiment for the day. So this is the infiltration test, and I consider it maybe a little bit more complex to set up, but it demonstrates some really great concepts that Stephanie and Joe will run through. So to me, again, layman's terms, is what this demonstrates is the effective land management, the ability of the soil to absorb and hold water. And I want to clarify that absorb means not just absorb, but also let water pass through. That's an important aspect of this test as well. So I think Stephanie's got a video of the setup, so I'll switch to that and she can talk you through some of the materials and setup here.
Yep. So again, with this video, I have collected soil, and for the purposes of this video, it does need to be air dry or well dried, just like that first video, that slake demonstration. So I will collect buckets of soil, typically from, again, like I said earlier, the top 4 inches of the soil surface, set it out on a piece of cardboard and let it dry. And what this soil is looking like, if you saw in one of those earlier videos, is that soil it's I want it to look like, when it's dried, what the surface of that field would look like when it's planted. So again, what are those aggregates and what are those particles all looking like? And so I measured out about 2 cups of soil there. I put it into that container, put a little bit of finer soil around the edges of that container, and then I'm tamping it in around the sides. I'm not pushing super hard, but just tamping enough to make sure that I'm trying to reduce or eliminate any preferential flow around the edge of that plastic container. Also, I kind of tried to show briefly, but the video wasn't super great with it, that those containers that I'm putting the soil in have holes in the bottom. So as we're putting that soil in there again, the management or the impact that we really want to look at is that ability for that water to pass through that soil. And the important part of this is those pore spaces and those air spaces and those root channels that we talked about kind of earlier on, that composition of a soil or how management affects the ability of that soil to allow water to pass through it. So we tamp them all down like that, and then once this is done here, I kind of just like level everything off, and we get ready to run the demonstration, which will be our next video here. All right, so like Seth said, this is maybe there's a little bit more preparation involved in this, but it's one of my favorite demonstrations because to me it's so graphic. And so for a layman out there who's not comfortable or thinking about farming all the time, this is even great to think about, and from a perspective of, great for stopping the video here, from the perspective of any type of landscape. When it rains, right, when I pour that water into those cups on the top of those containers and the water's flowing through the holes and onto that soil surface, is that water able to infiltrate? Like you see on the right there, right? That system where we had a healthy soil, so we have pore spaces and we have water stable aggregates. So you can see that water infiltrating immediately through those whole pore spaces and down into that container below. Whereas on the right, that soil, or on the left, I'm sorry, that soil, again, we didn't have pore spaces. And so that water is not able to infiltrate. So this is the one that's infiltrating. And here, the one on the left, that one is not infiltrating at all. So what we're going to see here in just a minute is that if you don't have infiltration, you have runoff. And that's one of the key things that we want to think about for a functioning soil with pore spaces and root channels, is that we want that water to go into that soil. And if it's not going into that soil, like here we have on this container on the left, that water isn't going to just sit on the surface of any field or any location. It's going to run off into a lake, river, or stream, or down into a storm drain, or wherever it can go to get away from that location. And that has a huge impact, again, on water quality, but then also on that soil, because that soil on the right, what I showed you there was storage. If water can infiltrate into the soil, we have water that's stored for later on in the growing season when a plant needs it. If water can't infiltrate into a soil, you have a soil that maybe dries out a lot quicker and doesn't have any water available for plants later on in the growing season. The other thing that's important to note here on this video, and you can kind of see it right here at the very end, that residue that's lining the top of that ring, right where that water is, right? When we have water that doesn't infiltrate, it carries organic matter and nutrients and other things away from that soil and washes it down into the river. We have a great residue ring there on the surface, on that container there on the left.
Before we get into the discussion points for this one, I guess I do want to talk about, like, if you are going to do all three, I think it is good, and we generally do them in this order. So we start with that slake, we get a good strong comparison, and we grab people's attention with that, and hopefully we've done that with you guys as well. You zoom in a little bit and you do that slump test, and you talk about the soil aggregates specifically, and how that soil is going to function or not when it gets wet. And then you get the opportunity to see how that soil functions by doing that infiltration test. So there's a little bit more of a story there if you have time to do all three of these, or have folks work through it, and you can build a little more in that way. But onto the discussion points for these, similar, right? So you want to talk about what those soils, how those soils were managed, and what practices were used on those, maybe. You want to talk about, do those practices increase or decrease that infiltration rate? Why or why not? if you've done the aggregate stability tests, then you can reference back to those, right? Because if they don't have good aggregate stability, those soils will break down and crust over or fill in those pore spaces and not allow that water to infiltrate. We talk about the rate of change from the first inch or the second inch. We don't typically with that demonstration measure the amount of water, but you can roughly gauge what an inch would be in that jar, and then pour another inch in there if you want. So after it wets up, do you have a similar rate or not? And these talking points are also used for an infield test that we do, where you take a 6-inch ring and pound it into the soil and actually measure. So you'll measure out an inch of water, you pound that ring into the soil, you measure out an inch of water, and you pour it into that ring, being careful not to disturb the soil surface, and then you time how long it takes to get for that water to infiltrate into the soil. And then you compare those. If it's particularly dry or just even not really wet, you want to do a second inch because you want to try to get to more of what a sort of steady state infiltration would be. But you can even do a third inch if there's time, right? So it doesn't sound very exciting to put words on a slide and talk about watching water drain into the ground. But it can be really interesting to do if you have the opportunity to do things in field. But if not, the jars with the air dried soils are a good way to bring that inside then too.
Hey, Joe.
Yep.
One of the things that I've done before with those infiltration containers is, as you know, you do that first demonstration, right, of putting the water in there, and then I had them sitting on some type of a rack, and what I've done is I've left them sit there for a few days, and kind of let them start to dry up a little bit, and then I've come back and actually rained on those soils again, trying to simulate what would be like in some of our landscapes and our cropping systems, where let's say we get 3 or 4 or 5 inches of rain over the period of a week, and start to get people to think critically about is that water infiltrating or not, and then if we're getting continued or more rainfall day after day after day, how much of that is actually continuing to go in the soil or continuing to run off. And you will actually see again, that unhealthy soil, that one that didn't have the water stable aggregates, that loss of function, that ability to infiltrate water, it actually gets worse and worse and worse. And that water will just sit on the top of that container. And then basically, you're just basically waiting for gravity to push that water through that soil profile. Whereas that soil with the water stable aggregates, it still continues to infiltrate water over time. So it is an interesting one to go back and look at again, a few days later or a week later, or other things like that, just to get people to think about that ability. Once you lose that function to infiltrate water, it's very hard for it to come back.
Mm-hmm. So then, of course, bringing it back to why that matters. I always try to bring it back to whenever I'm wrapping up with a group, why that matters for that group. So then you talk about what you saw in the demonstration or the test, and then what that means on a broader scale, right? So in a field, in a watershed, we have a lot of really important watersheds in the state here. So wherever you're at, I'm sure there is one. And everybody loves a stream or a river nearby. So you always try to tie it back to that. I think it usually lands really well. And we've got about 15 minutes left here.
Yeah. So I wanted to throw in a couple extra points here. And you got an extra bonus experiment. Joe ran you through a 4th experiment you can try in the field. So that's a really great addition. But I also want to mention that on Joe's last discussion point here is, talking about resiliency is, you know, the great thing about all three of these experiments is you can run all sorts of different scenarios with them. And this last discussion point, you can really think about, all right, how can we start thinking about how these soils react to climate change, right? And so I think there's some really neat ties you can make there. And then also, you know, the number of scenarios here are really unlimited because there's, you know, hundreds of soil types, right? And there's lots of different management types, and there's lots of different ecosystems too. So you can think about, all right, how does this work with forest soils? How does this work with prairie soils? How does this work with on maybe a compacted area versus a non-compacted area? So it doesn't just have to be agriculture and tillage. We framed it that way because we spend most of our time explaining it in those terms, but you could compare a lot of different things using this same setup, these three setups to really understand how soil functions under different management, but also under different natural systems too, and depending on what's in the soil and what the biology is like, things like that. So really you can set this up. If you didn't want to teach it from an ag angle, you could think about it from a natural system angle as well. So it looks like we have several questions in the chat, so I'm gonna let somebody that can see that maybe run through those. I'll switch to this resource slide and our contact information so you guys have a minute to write that down. So, but we'd be happy to answer questions in the chat, and if anybody wants to unmute and ask live, we're happy to answer those questions as well.
We did have one go by about if we can share these videos. And yes, I don't think we have them up anywhere yet. We have been frantically trying to get as much footage as we can to use over the winter while the weather is still nice. So I don't think we have any of our videos that we've done yet on any of our YouTube channels yet or anything, but Indiana NRCS does have a YouTube channel, and CCSI does as well. And Seth, I guess I don't know if you guys do. I'm sure you do.
Yeah.
I don't know if they've made them on there yet.
Yeah.
But yes, I don't think there's a problem with us sharing these videos. But Stephanie, they are yours. I guess I should let you speak to that.
Absolutely fine, Joe. I agree. Those videos were actually filmed on location right here in this space, and so they are. They're about as good as I was able to do at this point in time. I think the more I do this, the better I'll get. But absolutely, we can share those. I actually do have them loaded in a Box account, so I don't. If you want, I could maybe share that link to make them able to be downloaded. If people want that to be the case, I can do that, and I can share that with Stephanie and Joe and Seth. I can share that with you as well. Yeah, that's not a problem. Just trying to think about if there's anything else. There is a ton of videos out there, and you can spend a lot of time wading through videos. Lots of times I will go and I'll Google if I'm looking for videos, and I'll say something like soil health demonstrations, and then that usually helps me try to find some of the different videos that are out there. And there's some really, really great videos as well.
But not all of them are from McLain Studios, though. So.
No, most of them probably aren't. What else do we have here? Does anybody have any other videos or any other questions? If they feel free to unmute yourself, and I'm just trying to think about if there's other things that we want to discuss here. I think one of the things that I will bring up is, as you know, Seth and I actually I think I recognize some of these people's names here in the presentation today, Seth, maybe from our labs that we did at the zoo. But if you're interested in doing some of these things, just know that you aren't alone, and this isn't a vacuum that you're working in. There are a ton of resource professionals, conservation resource professionals out there that will work with you or partner with you to try to help get some of these things done on the landscape or demonstrations. In every county in the entire state, actually in the entire country, there's a Natural Resources Conservation Service office and a Soil and Water Conservation District office. And they usually have some type of an education person that works in those offices to help do some of these demonstrations or to help come into your classroom and do these things with you. Also, there may be, these people may have already collected soils and they have them available, or they'll help you find some sites where you can collect some soils. And that's also something that Joe and I and Seth have worked with as well, has done some of these demonstrations for schools or other events like that. So just know that even though we've talked you through how to do this as a lab in your class, that doesn't mean that you are, required to do this alone. There's a lot of support professionals out there.
Yeah, and this is actually what I would consider maybe an abbreviated version of a longer training that Stephanie and I have conducted actually at the Indianapolis Zoo with ag teachers specifically, but we're looking to kind of scale to all sorts of teachers that might be able to demonstrate these concepts in their class depending on what the subject matter is. And obviously agriculture and environmental science make the most sense for some of these things. So if you have interest in doing maybe an expanded version of this, we're always up for considering opportunities. So if you have other opportunities with this organization or other organizations that you might think would be a way to spread this content, we're always open to those conversations as well. So.
All right, well, thank you very much. We've got a couple minutes, so if there are any last questions, feel free to ask.
I would be interested to see where folks are from. We only have a few folks. So I'm just kind of curious where folks are from around the state. Darcy's a legend already, so Kosciuszko County is well represented. But I'm curious about the other three for sure.
I was just going to say that Darcy is a legend. Sure. But so is John and Teresa. They're also legends too. So, and we'll just put Stephanie Shuck in there as well. Like, this is like,
I'm still working on my legendary status. So
as am I.
Well, thank you, Seth and Joe and Stephanie. That was a great presentation. I know I learned a lot, and it took me back to my graduate studies days when I was taking soil resources and doing all these things in the lab. So that was a lot of fun. So thank you very much. I will see if I can add attachments in Whova to each one of the presentations. So I'll see if I can add. If you share a copy of your presentation with me, I'll see if I can add it to that. So that way people can get access to the links and things like that. But we'll make sure that whatever you're willing to share with us, I'll make sure that they can get access to that.
Yep. I can send that over right away so you can put it up ASAP.
Great. Thank you very much. All right. Well, thanks to everybody who joined us. Be sure to continue these discussions in the Whova app, and please make sure you fill out the online evaluations for each session that you attend. Also, save the date for the EEAI 2021 conference at Spring Mill State Park, November 12th through the 14th. And this afternoon, we've got some field trips scheduled throughout the state. So if you haven't checked on that, make sure you check on that and see if there's one near you, or you can do your own field trip outside somewhere else. So, all right. Well, thanks very much. We really appreciate your time.
Thank you.